this time or something. You know how it works. Okay, let's go. Let's go. Sharing screen. This one. Come back to our window. Very good. I see that something was changed in my Teams client. Some things was changed because my application today was upgraded. It proposed me to upgrade it. Okay, let's go. Let's go forward. Last time we talked about exceptions. I showed you probably something like 5 slides from this presentation. We didn't finish it, then probably today we will finish this part. In general, exceptions, it isn't part of parallel programming, but it's part of programming in general. And parallel processes are able to use exceptions. It's natural, it's expected, because as in normal code, as in linear code, serial code, the exception can happen. Exception can happen in your logic, in your code, or somewhere. As I gave you an example. One example we have on the screen. On the screen. Oh, I see there. The situation in which you would like to read the file, but file doesn't exist. What happened? The existence of file can depends on different parameters. Example, second application, external application should prepare it, but something happened in this application. Application didn't start and file doesn't exist, but our application is trying to read it. The file is absent. Then bad things can happen in our code, but we have a tool. We have a tool which can be used to prevent situation in which something can goes in unexpected situations. Something can goes in bad manner. Then we have exceptions and catching exceptions in general. In the previous presentation, I showed you how the exception is built, how it looks like. You can see it on the screen. I will try to explain it again very fast in a few moments. How you can create your own exception. It's the same situation, is the same information are on the set. The information how you can create exception are on the screen too. I don't remember what else was presented. Oh, I presented how to catch. I don't remember. We'll try to explain it again. Then we will see. But let's come back to the beginning. The exception is a class, like different types of classes. You can create an instance of class. Exception is possible. Creation of exception is possible too. Why not? But additionally, exception can be created by the framework in bad situations, in unexpected situation, like in this example on the presented on the screen, when file isn't exists. The exception is created by the system, the framework, which is trying to read the data from a disk, and data doesn't exist. Data doesn't exist. The framework create and throw for us a specialized, I say specialized because there can be different types of exceptions. I explain you in a few moments how it's possible. The environment, our framework is throwing for us an exception information which tell us that something went wrong. In this case, presented on the screen, we have file not found exception, which is built in the framework, which is exception built in the framework. This exception is built in the framework. There are many more exceptions built in the framework. Sometimes they are carried in with some kind of libraries, example, libraries to connection to database. Some kind of database can has own exception, like, I don't know, I don't remember. I won't try to remind in this moment, but example, if you are trying to connect to the database and database doesn't exist, or you don't have proper rights to connect to database, the exceptions, the proper exception, proper in the situation, in current situation, are thrown. And what you can do, you can catch them. You can catch them and make some kind of operations which made your application, some operation which made the proper situation in your application. Example, if you are trying to read the data and process the data, if you catch the exception file not found exception, you know that data won't be present, then you shouldn't process it. And you should choose the different path of program flow in this situation. Without the catching exception, program will throw an information that something goes wrong and program will be closed. It's all. But you know that you shouldn't left your application in your applications in this manner. Okay, as I told, we have one main exception which is used as a base class for different ones. As you can see on the screen, we have the custom exception, the class which is called custom exception, which inherits functionality of exception class. It means that this custom exception takes everything what is inside the class exception, like properties, source, helps, and so on, and methods, example, get type to string and similar things. Then, as you know, if you inherit something on base class, you can take properties and from this class, and you know that your class has own type, because in this example you have custom exception class, and in the same situation, in the same moment, has base class type. In this case is exception class. Then it's easy to discover, easy to understand that if you can throw an exception, or system can throw some kind of exceptions, In the same manner, your exception can be thrown, but of course, system doesn't know when to throw your own exception. You should know. You should know. Your code should know, and it can be conducted like something like control of flow in your exception in your application by exceptions. When exception happened, some specialized exception happened, you can check it, you can catch it, and make some kind of operation. Depends on the exception. Okay, we are going to the next slide, but before it, I will add one more information that I told that if you inherit from base class, you get your custom class has members and methods, has members and methods from the base class. It's true, except constructors. Constructors should be made, like in this example. Of course, you can omit some kind of constructors which you decide that they aren't useful. But the good practice told that in the exception case, if you inherit exception functionality, if you create your own exception, you should create a constructors. You should create constructors similar to the constructors in the base class. It's made for it should be made for I forgot the proper word. I forgot the proper word. Okay, maybe I remind it later. What I would like to explain, but in general, your class should looks like the base class. It could be helpful for use it in the future because you know how to use it, or everyone's your colleagues, your teammates knows how to use it. Exception class. Then if they meet somewhere custom exception class, then they can expect how they should use it or how they can throw it in general, because it has the same constructors. Then it's easier to understand how someone can use this kind of class. Okay, then we know that we have base class which can be thrown. We have built specialized exception class which are thrown by the system. Of course, you can throw it too. Why not? If the situation is proper, and of course, you can build your own. You can build your own exception classes if you need. If you would like to tell in your application to different parts of your application that somewhere went wrong, and you would like to define it in the precise manner. Because of course you could use the message only, but message is difficult to has some kind of difficulty to analyze, to segregate it, to put it in the proper flow in general. Okay, I told you that exceptions has some properties, source, help, link, and so on. These properties are described here. The most useful is a message which describe what happened. We have information that not only find not found exception, but in the message we have more precisely defined information. What happened in our application? Sometimes the message is used to display something to the user. Example, you can display something to the user, but the type of message is used internal in your code, or should be used, or can be used internally in your code, because you can detect differences between different type of exceptions. How to do it? I will show you in a few seconds. Message is the first one. Second one is the, I don't know, message is the most important element, the most important property. But of course, we have more property like inner exception, which can hold I can say child exception. Child exception is the second exception which is wrapped by our exception. Source inform us about assembly in which exception was thrown. Sometimes it's useful, and very useful is stack trace, because in the stack trace, I will show you an example. In the stack trace, we have information where exactly exception was thrown. Okay. Of course, we have more information. We have more parameters, like example, help link or something like this, but it should be filled by the programmer. If programmer expect that, if the programmer, how to say, programmer throw an exception, then it can fill it. Depends on the situation, depends on needs and similar things, but sometimes it's used, sometimes it isn't used, especially when you don't provide a manner in which you control your flow in an application by an exceptions. There is very often is omitted. Okay, how to catch an exception? How to catch an exception in your application? Everything is shown on this slide, but I will explain you step by step what's going on. Okay, first one, we had similar, no, we didn't have a similar slide. Then I will explain you that. You can imagine that you have something like a game, an application which conduct the game process. In the game, we have warriors. In this case, we have instance of an warriors saved, assigned to warrior variable. The new instance. Of course, in the bigger application, the instance should be taken from external and similar thing. But now I would like to explain you the exception catching process. Then the code is as easy as it can be. Okay, and if the warrior class has method fight. In the warrior class, we have method which tell us that the warrior can fight. And if we expect that in our method, in our part of code, in the sequence of code, can happen an exception, we can use try-catch structure. Try-catch structure. The try is the part in which we should write the code in which exception can be thrown. If we, example, are trying to open a file and we expect that file cannot exist, we should write it in a try section. And in the catch section, we can do something which happen in the moment when the exception will be thrown. It means that our application won't be closed unexpectedly, won't be thrown without information, but application did something or do something which programmer expect in the exception situation. As I told, if something happened inside the fight method, the code, the application won't stop working. The code will go to the catch part, In this case, it will be the information on the screen. Oh no, there was an error during the fight, and code will go forward. Nothing more will happen. Of course, you can imagine that the real world application are more complicated. Probably you should do something, you should make some calculation, you should stop some kind of process, example, return some information that something went wrong in your code. And probably in this situation, you should do some kind of operation, but in the easiest manner, there is everything. Then, next stage is, maybe I should say in another manner, that there was an easiest example how we can catch an exception. In the try part, we should write a code in which exception can be thrown. In the catch part, we should write something will be executed. What will be executed in the case of exception in the first part. Yes, but as I told, you can recognize the types of exceptions. In this case, it isn't possible because it's the easiest possibility how you can catch an exceptions. But on the right side, on the top right side, we have more complicated example in which we we recognize what kind of exception was thrown. There isn't very different. There is almost the same. We have a warrior. Warrior can fight. The fight is saved. The fight is written in the try section. And next we have two catch section. It can be one section, catch section, two or more catch sections, in which in the brackets we can put something like a parameter, of specific time. The type should inherit from exception, of course. It should be exception. I'm thinking because I feel like one as I lost one slide. I think something like this. One moment. Give me a second. I will try to find something on my disk. I'm thinking about previous version of this presentation. And I will see if I didn't lost. I didn't lost one slide because as I told, I feel like in the matrix, something should be. Oh, yes. Oh, yes, I have. I felt like in a matrix, like the situation in which the matrix has error. Something should happen, but it doesn't. Okay, I will copy it. Oh, sorry, something something goes wrong. I will copy it. I will put it here. Okay, and start it again. Start again. I don't know what happened, why I lost this slide. Sometimes it happened because example, by the accident something is clicked or something like this situation happened, and it was okay. Let's come back to our presentation. I will share again. I'm sharing again the screen, and let's come back. Okay, this is previous slide after this table. This is previous slides. In the first slide, I show you the custom exceptions. In the next slide, after this table, I would like to introduce a warrior class. The warrior class was used here. Where warrior class was used here probably. It probably is. And our warrior class isn't very difficult, and probably was explained during the previous presentation. We have in general class has fight and practice method. Practice isn't important in this case. Fight is important, but more we have energy level something. Probably it can be property or method. I can see, no, it's property because method is with brackets. I was thinking if the brackets are closed inside the this box, but probably not. There is a property energy level and skill level. Energy, you know, like in the fighter in the games or player in the games, you have some kind of energy and you have some skills. In this application are defined as a number, integers. And during the fight, your application can increase hunger level and decrease energy level. It means that our warrior should has method, something like sleep or eat and similar thing. Of course, the example is very, very easy then it isn't introduced here. It isn't introduced here. We have only small part and more during the fight. On the beginning of the fight, we are checking if energy level is lower than 10. If it's lower, then it means that probably warrior shouldn't fight because our energy after the fight can be decreased about 10. It means that we could went to 0 or below 0, and we don't accept the situation. Then in this case, when energy level is lower than 10, we throw and no energy exception. New no energy exception. New no energy exception is a new instance of some kind of class which inherit from exception. Throw, we are using throw to throw, to put information in the system, to blow information in the system that that something was wrong, something happened, something bad happened in our application. As you can see, we in our no energy exception, we at least one constructor which accepts a string, because we are able to put a string inside the brackets with a new word, new no energy exception, and string inside the brackets. And our no energy exception is defined on the right side, as you can see. It inherits from exception. It inherits from exception. It means that it takes everything what exception has, with exception of constructors, of course. Exception, it's too many words. Then it means that we take no energy exception takes from exception everything except constructors. Everything except constructors. Okay, then we can use it. We can use we should define the constructors if we plan to use it. If we have planned to use it, then we should define it. And as you can see, the constructors are defined, and more, because we are using a base constructors. Base constructors are contained in an exception method. Then, if no energy exception, if we use this kind of constructor, no energy exception with string parameter, the message, the parameter is passed to the base method. If we will come back to the base method, it means public class exception. If we come back, and we can see that this base method has base method has how to say, I'm thinking what to do with this situation. Mr. Luxon, please turn off your camera. It will be better for this moment. Thank you. Okay. As I remind you, the exception has constructors, and you can use it from inherited class, because you can use base method. Base method moves you to base constructor with the parameters message. Okay, there is some complication, but you can try to make some how to say, some experiments, and everything probably will be clear. Okay, and I can say again that we have no exception, like no energy exception. We have no energy exception. Exception is thrown somewhere, and if your application is working, you can see in Visual Studio, of course, if the application is working in Visual Studio, you can see the message that something went wrong. Exception of type hello world exception, no energy exception was thrown. Hello world exceptions, no energy exception is defined here, of course. Is defined here in the file. And if you are trying to throw it, the application behave like an exception is blown in your system. And to prevent unexpected behavior of your application, you should catch it with try-catch syntax. You should catch it with try-catch syntax, as I explained you earlier. As you remember, fight method, in the case when the energy level is lower than 10, will throw no energy exception. we are trying to use fight method, then we expect that because we create warrior, we know that probably energy level is very low, then we can expect that during the fight method execution, the exception will be thrown. Then code will go to catch part. In the catch part, something is made by our code. In this case, we only print information that the error happened during fight execution, nothing more. And if we will go to more precise information, we can detect what kind of exception was thrown. In this case, we have two detections: no energy exception and in general exception. Exception is the base class. Then it means that if no energy exception, if maybe in another manner, if exception is thrown, then our application will check if this exception is no energy exception. If is, then information will be printed on the screen. No, oh no, the warrior has no energy. No energy X message. No energy X is the variable which hold our exception thrown by fight method. In case when there will be different kind of exception, then code will omit this part and will go to the next part. We know that exception is the base class, then you can expect that this part of code will be executed in opposite case when different type of exception will be thrown in our application. But you can see that depends on a type of exception, different code can be executed. If the no energy exception will be thrown, this code will be executed. If different code, example exception, general exception will be thrown, this code will be executed. Then you can possibility to control situation. Example, if your warrior will have more than one exception, first one, no energy exception, second one, I don't know, no food exception, or next one, warrior die exception, or something like this, you can detect. Of course, different exceptions should be thrown in different situations during the fight. But if you have defined this kind of logic, you can detect what kind of situation happened without returning the information. The information are returned by an exception. And one more, your code doesn't go in somewhere in unexpected state. Your code is controlled, full-time controlled. If something happened, in the exception happened, you know what to do. Your code knows what should do in the situation. Of course, it isn't good to overuse exceptions because it needs some energy, some computing power and similar things than in the situation when you don't have, Oh, one more thing. Oh, because I see that I opened Polish version of our presentation. Sorry, I will come back in a few seconds into the English version because I copy from this version, this lost slide. Okay, yeah. You can see that you can control the program flow, depends on a type of an exception. And one more example. In this case, we had two types of exception. In this case, we have one typed exception. Next, rest of exceptions without defining a type. And one more possibility, use a throw word. Throw in this construction, in this construction will throw this exception forward. It means that the catch exception on the higher level of your application should catch the try-catch sentence on higher level on your application should catch this error, because example it's different than no energy exception. Okay, let's change our presentation to, let's come back to our first our English version. I opened it because I was looking for lost slide. Was 3rd or 5th? I don't remember. No, it's 5th. Okay. Oh no, again. The exception is in the bad place. Yes, I have to change position. Okay, F5 again. I believe that it's last time. The warrior class is presented here with our exception. Yes, you can see if you don't catch the exception, you can see that your Visual Studio will told you that in this place exception was thrown. In the real application, if it will be console application, probably you can see some information that something happened and the application will be will crash in this kind of situation. Okay, how to catch exception? I showed you how to catch exception. I showed you we have three methods in general. It's one method, but you can use it in different manners without the detection of an exception, with detection, or with detection and with detection of general error, and with throwing. It isn't obligatory because you can use a message like on the right side example. In this case, you can put more than one or two catch sections. Yes, you can put more than one or two. You can put the sections as much as you need. Yes. Okay, and one more possibility with final section. There is a final section. It's important part. It's important part of try-catch syntax. Something happened. Something was changed, but I think it isn't important. Warrior is created, like in the previous example. We have something like controller plus God of War. God of War. It means that God of War decide when something happened, and God of War created our warrior, or create our warrior, and we have make fight. We have made fight method. And first line, the warrior is prepared. We can see on the screenshot. Next, warrior fight. Next one, the warrior finished his fight. The warrior finished his fight. It's everything goes in proper manner. The next one. The warrior has to eat something. The warrior has to eat something. And last one, the warrior has to make practice. The warrior has to make practice and practice. What happens in this situation? We could see that the exception wasn't thrown. Probably the warrior was changed and the exception or energy level is higher than, in the warrior energy level is higher than 10. Then exception wasn't thrown. It means that our code in the catch section 1 and 2 wasn't executed, but the section finally was executed. The section finally was executed because in general, section finally is executed always. It's not depends if exception was thrown. If not, finally section is executed always. And it's very useful because you can use it, example, to close some resources like files, like connection to external resources, databases, and similar things. This code is checked if this part is checking if the exception is thrown is this code. This part did something in case, this part do something in the case when exception is thrown, and this part is executed always. This part is executed always. You can see that you can think that this part is executed always too, but it isn't true. It isn't true because in the catch we have return in the first catch. In the second catch we have throw. Throw will on this line throw an exception. Nothing more will happen except finally section. In the finally section, finally section will be executed in both cases. The warrior, the last part after try catch section, the code will be executed only in the situation when exception won't be thrown inside the fight method or in general in try section. Okay, I know that it's there is some kind of complication to understand, but in general it's easy. It's very easy. We don't have we don't have complicated logic in this description, in this syntax. It's easy to use. It's enough to make if it's enough to make some exercises to understand everything. You can rewrite the code presented and check how it works. It's enough to write some easy warrior class, some easy no energy exception, and try to use it, like in this example, and check what happened. Check what happened to understand everything on the examples, because it's difficult to learn everything from presentations or from books, from videos or materials in the internet or somewhere else. The best possibility how you can learn is execution, is experience, is work. I don't remember if I showed you. If I showed you, probably yes, but I would like to show you again. I will try to find something. It hides because I have many information in my phone. It's here. It's here. Okay. It's here. Probably I showed it. You saw it. Between beginner and expert is the hole, big hole, and big hole can be filled with your work. This big hole. Oh, I don't remember if you. I don't know if you saw it because I shared the screen. Then I will try do it again. I will try do it again. Between beginner and the expert is a hole, and you can fill it with a work if you will If you make your work, you will be the expert. But of course, it won't be in the next day. It will take some time. It will take some time. One more general information. If you would like to go somewhere, you have to make first step. And after first step, you have to make second step. And it's only one possibility how you can move from one place to the second place. Okay. Okay. Very good. Very good. I think. Let's go. Let's go. Let's go. Let's go. I would like to come back here and see what was thrown from which place, because message isn't enough. I don't know. Okay, let's see the information printed by the exception, which can be printed and which are held inside the exception. There are part of our warrior. It isn't very important what kind of part, what happened, and so on. Of course, we could analyze where everything, in which place the exception was thrown, but it isn't important, as I told. It's important that more important that exception carry some information. Exception carries some information which can be useful to resolve the problem or to do something with the situation. As you remember, the exception contains some properties, data, helping, inner exception, and similar things, and these properties are printed here. First information, data, system collection, list, dictionary, internal. Help link is empty, inner exception is empty, message. Warrior has only 0 points of energy. You can remember from which place it is taken. It's taken from this place. Yes, let's go. And more interesting thing, source. Hello World. Hello World is the name of application. Of course, in your application, you know what is the name of your application. But example, you can have more libraries, and in this place you would have informations about a libraries in which the exception was thrown. But the more important, the most helpful, the most important in the investigation process is the stack trace. You can see that stack trace shows you the precise path where your exception was thrown. In this case, it's warrior CS file, and in which line number 44 in this case. And because it's stack trace, you can see the stack of callings. You can see that the exception was thrown in warrior CS, but the warrior CS line 44 was called by God of War line 24. Line 24. Target site void fight. Fight is the method inside the Warrior CS. I think there are very useful and very important information, especially in bigger application, in the application which has more than 1 or 2 files, because there is possible to have applications like the bigger application, not only 1, 2, 3 files, but a lot of libraries, a lot of how to say, libraries, files, and similar things. I would like to show you something. Visual Studio. Let's open Visual Studio. Click. I'm waiting because it take few seconds before it will be opened. Everything is preparing currently. Okay. Okay. Let's go somewhere. I'm checking something, some codes. You can see that there are a lot of code of lines. It isn't good. These files should be divided to smaller, but we have something which can be called like, one moment. I will try to find the proper word. Oh, technological depth can be treated as technological debt. We sometimes decided to add some code to the same file, and files started growing unexpectedly. But if you can see 1, 2, 3, 4, 5, 6, I don't know how many, 10 or something like this, 10 projects, 10 more, 10 more, and 10 more, something like this. You can see that the application is built with, I don't know, 30 projects during the laboratories. We making only one project, nothing more, only one, with small number of files. In these projects, we have, I don't know how many. Example, let's go somewhere. I would like to go here, example. You can see that this project is the biggest one. We can agree that it isn't the smallest. It's big in general, but we have something like 20 folders. Each folder contains some files, as you can see. There is maybe 30. Let's go forward. Oh, there is more files. There is more. Oh, there are folders. Each folder contains 3, 4, 2, something like this. Files. Let's go forward. You can see that there is a lot of classes, a lot of files, a lot of code, a lot of codes inside this application, as you can see. Yes, and without any informations contained in the exception, during the exception, of course, it won't be possible to detect where the exception was thrown. What is the reason of an exception? how it looked like. Everything in the shown application is saved in the log, in the database log. It means that each exception is saved with an information where, which method, in which file, on which line. Sometimes we have added some more information like parameters of a method. We saved two to detect, to find the to find to find the reason, what happened, what was thrown. This application has the parallel code too. You can imagine we had an examples how difficult is parallel code to conduct. More, this application contains one more English word. Oh, distributed. I forgot this one. This application contains distributed programming, which means that distributed processing, which means that depends on situation on one computer. The situation on second computer can be changed. There is communication between computers, not only to database, but between computers too. Not exactly between computers, because we are using something like messages aggregators, the hub of communications, It means that communication doesn't go peer-to-peer between computers, that it goes to the hub, and hub distribute messages. But you can imagine if you have troubles on one computer to make parallel programming in good manner. As you remember, something can be mixed, some kind of result can be mixed. What we can say about distributed processing, when you have not only parallel processing on one computer, but you have parallel processing on many computers, and you have to synchronize it. There is difficulty to example find the source of the problem. Of course, everyone tries to make his best work during the programming process, but sometimes it isn't possible to discover every strange situation. Sometimes strange situation went blow up earlier during the tests or during the production process, during the production work. Then information which are holded inside an exception are very important, and information within the example data section, which can be filled by a programmer, collection of data defined by the programmer about exception, can be very useful because they can be holded and moved somewhere. Example, to the system which save information for later, to analyze for later analyzing. Yes, but then please believe me that cooperation with an exception is very important. And in this manner, one more information, because I showed you that we can print it on the console in this case. Of course, the applications aren't very often console applications. Sometimes the services or something like this, which are run from an scheduler or similar things. But very often there has graphical interface or web interface or something like this. But during programming process, you can see the exception. Like in this case, probably you saw it in your application. If you made mistake, the code is able to stop somewhere on some kind of bad operation, like division by 0, example. Something like this can happen, and you can see the unhandled exception window. And if you click View Details, you can see window like this, like presented on the screen, and you can see data, inner exception, message, source, stack trace, and similar things. They are they are holded with an exception. In the Visual Studio, you can see it. During programming execution, you can't, but you can catch it and you can, example, save it or do something which is important in this situation. Okay, one more slide. I don't know if one, maybe more slides about an exception inside, about exception catching. An exception catching with tasks in general. Okay, let's show something here. What we can do. There is a simulation of strange situation. There is a simulation of strange situation. Unexpected, it means exception. Yes, we create a new exception and we throw it. It happens, it behave like an error in your application, like an exception in your application. You could do something else. Example, you could make division by 0 or some strange operation. You could open the file which doesn't exist, and it will behave in the same manner. Sometimes to test something, it's used. And as you can see, in this code, we don't have try-catch section. The try-catch section happen on the white method, because the task is the holder for our code executed in different tasks, in different thread. And we have to have on this line, we only defined what happened, what kind of method should be executed, and we have defined something like anchor to our code executed somewhere in different thread, in different place in our computer. And if we would like to catch the exception, we should wrap a task wait inside. We should put task wait into the try section. In this situation, if the exception is thrown inside the method which is executed in different thread, we are able to catch the exception. As you can see, the exception is printed on the screen, on the console, and you can see it on the left part of our application. The stack trace is started here. You can see that there is task example method. Probably it's called outside of run, or console app for task example. Probably it's class. Task example is class which has method run. As you can see, it's possible how you can catch, in which manner you can catch exceptions inside the task, inside the code which is executed in different thread. I would like to remind you again that this line of code is only for presentation. You shouldn't write this kind of code in your production code. This is only for show. I would like to show that what happened if an exception will be thrown. But of course, you can do your own exception, like in the warrior, in the example with our warrior. You remember that our warrior has defined no energy exception. Exception can be thrown during the fight is energy level is below accepted threshold. Then it's possible to control program flow with an exception. But in this case, this line isn't obligatory. This line is only for presentation purposes, only for it. But of course, try catch is useful in case when somewhere in this code will be the exception will be thrown. You have to remember about it. You have to remember about it. Then again, if you would like to try catch, if you would like to try to catch the exception from task, you should put the task weight inside the try section. In opposite manner, you could think that the best option is to put task creation in the try catch section, but it doesn't happen. It doesn't happen because in this place we only define the task, and we have an anchor for the task with a task variable with our task from small letter. And if we would like to catch an exception, we should put task weight into the try section. Okay, one more information. What happened when we have more than one task? Of course, each task can be holded, can be put inside the try catch. But of course, we can example use task when all method. If we have second task which is catched inside when all method, there is a connection between tasks, and you can put this task inside the try section, and in case of exception, the exception in this case will be printed on the screen, because our code only prints on the screen. In normal real application, real life application, in production application, probably it should be written to the log file or database file or someone information about exceptions. And the state of an application, of the objects of application, should be stabilized in some manner. The resources should be closed, and similar thing. One more with wait all. With wait all, if you would like to catch exceptions, we should put task wait all inside the try. In general, the part of code which is waiting for the result, which is waiting for the result from task, should be put inside the try section. This is only one possibility how you can catch the exceptions from our task. And one more slide. I don't know if only one, because I have one. Oh, it's only 2 slides. It's only 2 slides about exceptions. I would like to show you the situation in which we have defined two tasks, but the second task, it's inside the first one, as you can see here. Yes. I'm watching what happened, what is difference between this one and this one. I don't remember, but it isn't very, very important. The most important thing is that we can see on this on the screen. Start task execution. The task is prepared. We know that it take some time. Next, end task execution. Next, execution time is printed. As you can see, execution time is printed. And next, task wait method is started. Of course, task method is wrapped inside the try section. It means that in case of exception, the catch will print information about exception. Then let's go inside our task. And our task first prints parent task started. What we can see on the screen, parent task started. Next, we have created second task inside our parent task. It means that our process, which is executed in different thread, is creating own process which will be executed outside this thread. And the task is executed. The method print numbers is executed too. Next one, parent task started was printed, yes. Next one, the method is executed. I don't know how long it should take, but next one we have child task started information. Then it means that our task is started and our print numbers is executed. Our method is executed, but it should take longer. And next information, parent task finished with the 0. As you can see, there was only one number. Then redval probably, if you remember the method, it should join some strings, some numbers to the string. Then our task finished is printed. And next one, our print numbers to 20 is printed. And it's all. It's all. Where is our child task finished? In different situation, or maybe we should expect that our exception, because our task wait is wrapped inside the try. But as you can see, our task, which is defined inside the task inside the task, we can say, probably I should change the name, but only it's possible to define something like this, 2 times task, because this task is outside of a range of this task. It's possible to have 2 times the variable of the same name, but in the different range, As you can see, this task isn't the same like this one. But more important thing is that these two tasks aren't connected between them, aren't connected. We only defined it in this place, but they aren't connected. Of course, they can use the same data or something like this, but they aren't connected. Then, because we didn't catch the exception from this task, the tasks aren't joined together, then we lost information. We lost information about exception. And there is a possibility how we can join these two tasks. we can use parameter task creation option attached to the parent. As you can see, there is the same situation like in the previous slide, with exception that we added additional parameter during creation of task. In this parameter, we attached our task to the parent. The parent for our task is this method. And as you can see, our main task, our first task in general is wrapped inside the try section. Everything happened like in the previous example, with an exception that, with the difference that when inside the second task exception is thrown, we catched it inside the catch section of our try catch. You have to remember about it. You should remember that tasks aren't connected, but you are able to join them, to make, how to say, logical connection or physical connection between them. Some kind of communication between these two tasks can happen. It's the possibility how we can traverse message, how we can traverse exception from one task to second task and to catch section in general. Okay, I believe that that you will be able to make some kind of exercises about it. Probably we don't have, I don't remember, you will see. Probably we don't have laboratories about it. As I told you, I don't remember exactly if we have special laboratories. Maybe it's used somewhere that you should, it's information somewhere that you should make an exception handling. But I propose you to make some kind of exercises. Some exercises with exception handling, with exception catching, because it's useful. If someone would like to be a programmer, and if you don't know how to use it, or you don't have an experience with this subject, you should try to earn this experience. And I can say more, that the idea of exception catching is in many languages similar. Then if you will learn how it works in one language, programming language, probably there will be more languages in which the exception catching works in the similar manner. Okay, for today is all. I thought that we will make more, but if not, it isn't a problem. We will continue during the next presentation, during the next Friday in general, if I remember correctly. Probably yes, probably next Friday will happen, because we'll have Christmas holidays. It will take 2-3 weeks, something like this, near near the December, somewhere in the December. Okay, thank you for today. We will see.
Excuse me, Professor.
We will see. We will see during laboratories in the Monday, if I remember correctly. And it's all.
Mark my attendance.
What's happened, Mr.
Prosper, yeah.
Prosper, sorry, Prosper.
Yeah, I was late.
Okay.
And I think you were done marking the attendance the time I got it.
Okay, if you are here, I'm able to give you an attendance. Why not? Because I remember situation when someone came I don't remember, 1 week or 2 weeks later and ask me about attendance. No, 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 it isn't possible. But if you are today, I can give you
Yeah.
Prosper Muszoriła.
Tak.
Tak, oh. Do you know Polish language?
Trochę po polsku.
I rozumiesz, co się do ciebie mówi, czy tak średnio?
Mówię, nie. Dziękuję, do widzenia. Spoko.
No to dobrze, to dobrze. Something was wrong. Oh, I see that there are more.
Dzień dobry.
Dzień dobry.
Yeah, about the wisdom. I came in late. I was trying to look for the
Okay, I
the
will
link
give
for the
you.
class.
I'm giving you a presence like for your colleague.
So thank you very much.
Thank you. Thank you. Mr. Norris Chikusa.
Yes, I had challenges with my connection at the beginning of the lecture.
Could you repeat?
I was having challenges with my connection at the beginning of the lecture.
I understand that you have the same problem. You would like to have attendance.
Yes, sir.
Oh, very good, very good. I understand because on the first moment I thought that I should repair your connection or something like this, but no, you need an attendance. Okay, I gave you attendance. I mark your attendance. Thank you.
Thank you very much, sir.
Thank you. Mr. Norest was marked. Then I see that the almost everyone's left our meeting. Then I would like to wish you good weekend, probably good weekend. Thank you. See you later.
Bye-bye.
Bye.